Bismillahirrahmanirrahim. Assalamu alaikum. Let's today solve some practice problems on the one-sided limits. So this question says for the function g of x graphed here, find the following limits or explain why they do not exist. So we have a graph of a function y equals g of x, and we need to find the limit of the function as x approaches 1, as x approaches 2, as x approaches 3, and as x approaches 2.5. So let's start with part A of the question. So to determine the limit of the function as x approaches 1, we have to find the one-sided limits. So first let me find lim g of x as x goes to 1 from left side. Well, we are talking about the region where x is less than 1. X approaching 1 from left side means x is in this range, very close to 1 and to the left of 1. Minus means to the left of 1. We are talking about the region where x is to the left of 1. So the graph of the function is this straight line, which you see in the region before x equals 1, or to the left of x equals 1. So as x is approaching 1, the value of y is approaching 1 as well. So you can see here at this point at the origin, x is 0, y is 0. If we move to the right, the value of y is increasing until we reach 1. So just before 1, the value of y is equivalent to 1. And then we have to find the right side limit, lim g of x, as x goes to 1 positive. Positive means we are approaching x equals to 1 from right side. So we are moving from 2, let's say x equals 2, and we are approaching x equals 1 from the right side. So we have to find the graph of the function in this region. So this is the graph of the function in this region, the graph between 1 and 2, this line. So as x is going towards 1 from larger value to 1, because we have to approach 1 from right side. So we start from a value of x like 2, 1.5, 1.1, until we reach 1. Then you will notice that the value of y is approaching 0. So this limit is equivalent to 0. Since the two-sided limits here, the right side limit and the left side limit, are not equivalent, then we will say lim g of x as x goes to 1 does not exist, or just without s. Okay, D and E, or does not exist, does not exist. You can say D and E, and we have to explain why, because lim g of x as x goes to 1 from left side does not equal lim g of x as x goes to 1 from right side. So the two-sided limits are not equivalent. That's why the limit of the function does not exist. Now we have to do the same thing for the next value of x. So for b, we'll talk about x equals 2. So the next point will be as x approaches 2 from both sides. So we have to find the left side limit and the right side limit. So lim g of x as x approaches 2 from the negative sign. Okay, from the left side of x equals 1, we have to follow this line. So as x now is approaching 2 from right side, means we start from 1, 1.5, 1.8, 1.9, 1.99. So we are approaching 2 from left side. The graph of the function is increasing to 1. So the y value is approaching 1. Now if we want to find limit g of x as x approaches 2 from right side, we have to follow the other graph in the region that is greater than 2. This line which is between x equals 2 and x equals 3. So as we are approaching 2 from right side, means we start with x equals 3, 2.5, 2.3, 2.1, 2.01. We are approaching 2 from the right side. Then the value of the function is going up to 1. So as x is getting very close to 2 from right side, the value of y is getting very close to 1. So the limit is 1. So the two-sided limits here are equivalent to each other. Then we will say lim g of x as x goes to 2 equals to 1. In this case, the limit does exist and is equivalent to 1. Now for the as x goes to 3, the next point is as x goes to 3. Again, we have to find the two-sided limits, and lim g of x as x goes to 3 from left side, it's equivalent to 0. And also the lim g of x as x goes to 3 from right side is also 0. Hence, lim g of x as x goes to 3 is equivalent also 0. Now the last point is the limit as x goes to 2.5. 2.5 is here in the middle between 2 and 3. And if we approach x equals 2.5 from both sides, you will find also the limit exists. And the value of the limit is actually, in fact, we can find that value. To find that value from the graph is difficult to find it because we don't know the values between 0 and 1. There is no scale. But to find this value of this limit, we have to find the equation here of this line. So because the point here is 2.5, if x equals 2.5, we don't know what the value of the function is, but we can find the equation of this straight line. So for this point number D, I will leave it to you as an exercise. You think about it. So what you need to do here is you need to find the equation of this straight line. And I'm sure we'll be able to find the equation of a straight line because you know the coordinates of this point, you know the coordinates of this point, and then you apply the equation for the straight line, you find the relation between y and x. And that will be the function g of x. So y will be equivalent to g of x. And once you find that, then you find the limit of the function as you approach x from left side to 2.5 and from right side to 2.5. So once you find it, then you will be able to find the limit of the function. So I leave part D as an exercise for you. If you still cannot solve it, I will show you during the class the solution of this part of the question. Now next, so for question 2, yeah, almost the same idea. We have another function s equals f of t, and we need to find the limits of the function at x equals -2, -1, 0, and 0.5. And if the limit does not exist, we have to justify that and we have to explain it. What I will do here, I will leave part A and part B and part C because they are similar to the previous question, and I will see part D. Okay, part D at t equals 0.5. So I will solve only part D, but I will give you the answer. I will give you the answer. Okay, I will give you the answers for the part A, B, C, and D. I will solve it in details. Okay, but you have to do the details of the solution of parts A, B, and C. So for A, we need to find the limit of the function as x approaches 2 from both sides. So lim of f of t as t goes to -2, it will be 0 because the two-sided limit is equivalent to 0. And for B, lim f of t as t goes to -1 is equivalent to -1 because the left side limit is -1, the right side limit is -1. For C, lim f of t as t goes to 0 does not exist. Why? Because the left side limit is -1, the right side limit is 1. Now for part D here, for part D, well, if you approach the f of t from left side as t goes to -0.5, -0.5. So -0.5 is this -0.5. And let's approach this from the left side, means we put the negative sign on the top of -0.5. Then as we approach x from left side, the value of the function will approach this value. Now, in this interval between x equals 0 and x equals -1, the value of the function is constant. It's equivalent to -1. And we said the limit of the constant function is equivalent to the value of the function. So the value of y in this interval between x equals 0 and x equals -1 is always -1. So if you approach x equals -half, which is in this interval, from left or from right, the value will be -1. So this will be -1. The same thing for lim f of t as t goes to -0.5 from right side, which is also -1. Hence, the limit of f of t as t goes to -0.5 is equivalent to also -1. So this is the solution of this question. Now let's see question 3. For question 3 here, for the function f of x, find the limits at the following values of x equals to 0, 1, and 2, or explain if they do not exist. Well, this kind of function has a name. We said the name of this kind of function is piecewise defined function. It means that in each interval of the domain or of part of the domain, the function has a specific rule or a specific equation. So f of x will be equivalent to square root of 1 minus x squared if x is greater than or equivalent to 0 and less than 1. And the value of the function will be 1, means y equals 1, if x is greater than 1, less than 2, and the value of the function y equals to 2 when x equals to 2. So the function here is defined into 3 intervals, between 0 and 1, between 1 and 2, between x or at x equals 2. So during these 3 intervals, the function will have different values or different relations. So let's say at x equals 0. At x equals 0 here, we want to find the limit. So lim f of x as x goes to 0 from left side. As x goes to 0 from left side, where is the function? What is the equation for the function? The function is not defined. For values of x less than 0, the function is undefined, because here the function is defined only for values of x that is greater than or equivalent to 0. So here the limit does not exist. Okay? The limit of the function as x goes to 0 from right side means greater than 0. We have to follow this equation. F of x equals the square root of 1 minus x squared, because this is valid for values of x that is greater than 0 and less than 1, just greater than 0. So we have to use this equation. So we will say this is equivalent to the limit of square root 1 minus x squared as x goes to 0 from right side. So we did learn in the previous section how to find this limit by substitution. So you substitute instead of x 0, then we'll have this, and the answer will be 1. So the limit here is 1. But this right side limit is different from the left side limit, so we will say lim f of x as x goes to 0 does not exist, because the left side limit does not exist, then the whole limit will be does not exist. Okay? So this is the solution for the first part at x equals 0. Now the second part at x equals 1. Let's find limit f of x as x goes to 1 from left side. Okay, so we have to find the function in this region. When we say left side of 1 means less than 1. So the function again, f of x equals square root of 1 minus x squared is used for all values of x that is less than 1. So this is the limit of square root of minus x squared as x goes to 1 from left side. So yeah, so again we'll use the substitution. You substitute x by 1, not minus 1, 1. So 1 squared. So this will be 0. So the left side limit as we approach x equals 1 from left side is equivalent to 0. Now we will find the right side limit. Limit f of x as x goes to 1 from right side. From right side means we are talking about x greater than 1. So when x is greater than 1, we cannot use the first relation here. F of x equals square root of 1 minus x squared. We cannot use it because this is valid for values of x less than 1. Here we are talking about values of x greater than 1 and less than 2. Yeah, very close to 1. So we have to follow this relation in the middle. So the value of the function or f of x will be 1. And this is a constant function, right? And we said the limit of a constant function will be the same function. So here we'll say lim f of x is equivalent to lim 1, lim the 1 as x goes to 1 plus. So the function will be equivalent to 1. So f of x is equivalent to 1. So instead of f of x, we write 1. And the limit of 1 is 1. this is from right side. So here we can say at x equals 1, the left side limit is 0, the right side limit is 1, hence the limit at this point does not exist. So we'll say lim f of x as x goes to 1 does not exist. Why? Because the two-sided limits, the two-sided limits you can write like this, are not the same or are different. They are different. Okay, these two-sided limits are different. The left side is 0, the right side is 1, so they are different. What else? At 2. Okay, so the limit at x equals 2 for the left side limit is equivalent to 1. For the right side limit does not exist because the function for x greater than 2 is undefined. So again we will say here lim f of x as x goes to 2 from negative side is equivalent to lim 1 as x goes to 2 from negative sign, because when x is less than 2 we have to follow f of x equals 1, so the function will be constant and its limit is equivalent to 1. And the limit from right side is undefined because the function does not exist. There is no function, okay? So it does not exist because there is no function, hence lim f of x as x goes to 2 does not exist. Why? Because the two-sided limits are not equivalent. So this is the way we solve questions using the analytical equations. Okay, so question 1 and 2 was about finding the two-sided limits or the limit of the function graphically, and question 3 is finding the two-sided limits and the limit of the function analytically. There's one more question, question 4, this different function, and we have to find the limits of the function. I will change these, okay? Find the limit of the function at x equals 0, okay? At x equals 1, not 2, make this equivalent to minus 1. So this is minus 1. So we have to find the limit at x equals to 0, and at x equals 1, and at x equals minus 1, okay? Not 2, minus 1. Analytically by using the equations, okay? So try to solve this at home. If you cannot, then we can discuss it in the class. I will stop here and then I will see you in the class inshallah. Yalla, bye bye. Assalamu alaikum.